The last of our alterations to the sine and cosine functions are change of the basic interval. The change of the basic interval. And by that we mean this. If inside these parentheses, if the expression is more than simply x, if this is 2 times x, or 5 times x, or negative x inside the parenthesis, if this is x plus 2 inside the parenthesis, if this is any alteration other than simply the variable x, then this is a change of the basic interval. And to graph this, we're going to use just a standard algorithm, a standard procedure. Not a whole lot of explanation, just this is the procedure to use. So here's the process we're going to go through. First, as before, right, we're going to go through and state the basic shape. We're going to state the amplitude. We're going to state the vertical shift, if any, and then we're going to talk about the basic interval. Now, here's what I mean by the basic interval. For the basic function, f of x is equal to sine of x. The basic interval, remember, the basic interval is the interval from 0 to 2 pi. 0 to 2 pi. That's the basic integral for the sine curve. Same thing for cosine. If this were g of x is equal to cosine of x, the basic interval would be from 0 to 2 pi. Now, it's going to be more convenient for us not to write it in this interval notation. What we're going to do instead is use this notation. 0 is less than or equal to x is less than 2 pi. This is the interval over which we're going to graph these functions. If it's sine or cosine, this is what we're calling the standard interval. If it's sine of x or cosine of x, this is the standard interval. We will not use the interval notation. We will use this notation along the number line. 0 less than or equal to x is less than 2 pi because that's the standard interval for sine and or cosine. Now, if there is anything in these parentheses other than x by itself, this is the procedure. But if there's any value in here other than x, we're going to take that into account when we work. This is what I'm calling, this step is what we're doing. We're taking into account the basic interval. So when we do this step, and there's going to be more to it, we are taking into account the basic interval. And I think the simplest thing is like teaching somebody to ride a bicycle rather than explain it and explain it and explain it. The simplest thing is just to show you how it's done. So here we are. We have the graph. We're going to graph f of x is equal to sine of 2x going down exactly the same checklist as we did before. So what is the basic shape of sine of x? The basic shape, right? Basic shape of positive sine. So far, that's the basic shape. What is the amplitude? Amplitude is the coefficient of the sine. Coefficient of sin, coefficient. The coefficient, absolute value of that coefficient is absolute value of 1. So the basic shape, amplitude is 1. Is there any vertical shift? Vertical shift. There is no vertical shift because we're neither adding nor subtracting anything from our function. So the vertical shift, there is none. If there is no vertical shift, you don't leave it out. You don't leave it blank. If there is no vertical shift, you actually write the word none. That way I know that you've taken that into account. And then here we are. Now we have the basic interval. So every time you graph one of these, every time you graph any function of sine or cosine, any function of sine or cosine, any of the examples we've been doing so far, you need to have these 4 steps written out every time. These 4 steps written out every time. And when you fill them in, we're going to fill them in from bottom to top. Here's how to handle. We haven't yet talked about how to do this. Here's how you handle this step in basic interval. You take the standard interval, 0 less than or equal to x less than 2 pi, but inside, in the interior here, this is what we'll do. We're going to write 0 less than or equal to, leave a space, is less than 2 pi. Leave a space. In this space, put what's in those parentheses. In this space, put that expression. 2x. Whatever is the argument for sine, whatever that is, whatever's in those parentheses, put it here. Now, solve for x. Solve this extended inequality for x. And the way we're going to do that is isolate, get x in the middle. Isolate x in the middle. That is to say, in this case, we're going to divide every term by 2, or multiply by 1/2 if you wish. And so I'm going to write this here. I'm going to say 0 less than or equal to 2x is less than 2 pi, which means you multiply everything through by 1/2, or we can think of this as divide by 2, divide by 2, divide by 2. 0 divided by 2 is 0, is less than or equal to x is less than, the 2's cancel, pi. This is now the interval over which that graph needs to occur. Start with the basic interval, put this argument in the middle, and then solve for x in the middle. Isolate x in the middle. All right, so let's do that all over as if from scratch. I'm going to do this all over as if from scratch. At least this basic interval portion. Basic interval. The vertical shift is none, amplitude is 1, basic shift is the basic shape rather. The basic interval goes from 0 less than or equal to, leave a blank space, is less than 2 pi. So this is our procedure for the basic interval. All right? And so in here we take whatever's in the parenthesis, put here. Whatever's in the parenthesis goes here. Solve for x. So divide by 2, divide by 2, divide by 2. We have 0 less than or equal to x, which is less than pi. This is the interval over which this graph needs to occur. And so here we are. There is no vertical shift. So here's 0. This needs to go from 0 to pi. So I'm going to, when I say go from pi, we're still going to go here up, but then this is going to determine the sidelines. So the vertical shift, there is none. This is still the axis of the function. The amplitude is 1. So we have positive 1 and negative 1. So there's the peak line. There's the trough line. And then the basic shape has to fit in here. Now, here's the peak, here's the trough. Remember, we need our sidelines. This tells us the sidelines. Right? This tells us the sidelines. So the peak line tells us the top line. The trough tells us the bottom line. These sides are determined by this basic interval. So we have one at 0. Now I need my horizontal scale. Here's 1, 2, 3. Here's pi. But look, that's the sideline. The entire picture needs to fit in that rectangle. Which means, you gotta be careful. This is pi over 2. Right? This is pi over 2. This is pi. But we still need half of that. This is the next skill you need to develop. If this is pi over 2, we need 1, 2, 3, 4. We need to break this into 4 different pieces. But we only have 2 here, so you need to cut them in half again. What's half of a half? This is pi over 4. And the way you count this is 1/4, 2/4, 3/4. 1/4, 2/4, 3/4. And now we have our 4 subdivisions. We put in our 5 points and we're good to go. Node, peak, node, trough, node. And so this basic shape fits in. We determine top and bottom by the amplitude and the shifting. We determine left and right by the basic interval. And then if you only have 2 of these, you have to subdivide these into fourths. 1/4, 2/4, 3/4, 4/4. So you label this picture correctly. So we'll go through several examples of this to make sure you get the feel for it. And it doesn't take nearly so long if you don't explain it as you go.